We have a bit of a guessing game for you, and we want you to think about, just looking at this little area that we've identified here, how many turbines do you think that we are going to build here? Our answer is 277 wind turbines. Okay. So now you know where we are building the wind farm, but can you guess why? Why do you think we chose this area? What would make it a good place for a wind farm? Okay, so Caitlin, do you want to show us? The first answer is definitely wind. You can't have renewable power without the natural wind resource. And the North Sea is one of the windiest places on Earth. This makes it ideal for a wind farm location. Okay, so our second reason why we've chosen it is it's far from the shore. Some common complaints about wind farms are that they are noisy and they're not very nice to look at. So Dogger Bank is far away from any people, so this won't be a problem. And then thirdly, whoever said it's shallow is correct. With it being shallow water and a sandbar, the sea at Dogger Bank is not very deep. This means that we can have the traditional fixed-base turbines that reach the seabed. If the water was deeper, we would have to use floating wind turbine design, which is much more expensive to build. Okay. Next slide. So renewable power is managed by the UK government as part of the net zero commitment. And our wind farm, like all other renewable power plants, are required to get permission from the UK government to start construction. The net zero carbon strategy outlines the UK's commitment to reduce the carbon emissions. It's first of all 41% by 2025, 78% by 2035, and net zero by 2050. In 2008, our Dogger Bank farm was included in the third license round for offshore wind, and it was the largest and shallowest zone in that round. There was careful assessment, development, and engagement that happened before the project was awarded, and consent was received from the UK government in 2015. In 2020, it was announced that GE's Haliade X would be the turbine to power the Dogger Bank wind farm. So you can see it takes many years of planning, consents, and careful work before we even start construction of the wind farm. Next slide, please. Construction of the wind farm is a very challenging process, requiring many years of planning, costing, design work, which is engineering, drawings, approvals, and consents, before we are even able to start the many years of manufacturing and construction activities. Construction and installation of the infrastructure needs to be complete before the construction of the wind farm itself. This includes the subsea and underground high voltage cables, the converter stations and substation infrastructure, and the marshalling harbour at Abelseton Port, where we will do some construction activities onshore on the components prior to them being sent offshore. So it makes it a little bit easier for them to install offshore. We have a short little video to show you about the current progress of the project.
More than 130 kilometres off the Yorkshire coast, some of the world's largest and most powerful wind turbines are now generating renewable energy for UK homes and businesses for the first time. Our journey to first power hasn't been an easy one, with a global pandemic, a conflict in Europe, and some challenging weather events. But our dedicated team and expert supply chain have delivered against the odds. The numbers speak for themselves. Hundreds of kilometres of cables onshore and offshore. Dozens of UK-designed foundations. 1 completed offshore substation, 1 onshore converter station delivered, 1 operation and maintenance base in action, more than 2,000 UK roles created or supported. And this is just the start as we continue to deliver the world's largest offshore wind farm and leave a legacy for future generations. We are Dogger Bank Wind Farm, a vision of the future of green energy.
Any questions so far? Okay, carry on.
Oh, we have one. How much energy do you think it could produce in over a year?
So we did address that in, I think it was slide 2. We will be able to power 6 million homes annually. So that means every year that when the Dogger Bank wind farm is completely constructed, it will power 6 million homes every year.
And what materials are used to make the wind turbines?
There are some more slides coming up about what materials and how our turbines are made.
And how much does it cost to install the wind farm?
Unfortunately, we do not have that information, but it's billions.
When is the wind farm due to be completed?
So far, our wind farm is due to be completed in 2026.
Was it difficult for us to operate during COVID?
Luckily not. Our business is set up so that we can work remotely if required. And there may have been some delays in consents with everyone, thinking about COVID rather than building new wind farms, but we were able to progress.
We have a question about how many people will be employed and if local labour will be sourced, but I think we have some slides later on in the presentation that cover that topic. And then we have, is it a dangerous job?
Some of the jobs can be very dangerous. We have a lot of work that takes place at height. You'll see a little bit later how tall our turbines are. But we have a lot of safety protocol in place to keep people safe.
And we have another question that I think is covered later in the presentation about what happens if the wind area is not windy. But I think we cover that later on, so I'll leave that one for now.
Great questions, thank you. Hand over to Charlotte, thank you.
Hi everyone, I'm Charlotte. I'm a project management engineer on the Dogger Bank wind farm. So GE are currently producing a turbine called the Haliade-X, which is the largest, most powerful offshore wind turbine that's ever been produced. We're currently working on the Dogger Bank wind farm, where we have 12 of these turbines offshore currently, and as we said, we'll be installing a total of 277, which will power 6 million of our homes. Hopefully you'll learn a bit more about how a wind turbine actually works through this next bit of the presentation. So here you can see our components. Our Haliade-X wind turbine is made up of 3 different components: the nacelle, the tower, and the blades. All the components that we use are manufactured and produced in GE Vernova factories in France, Spain, and in China. They're then shipped across from the factories on huge vessels to Abelseton port, where the cranes then lift them off the vessel and onto our site. We then store them and look after them, fixing anything that was damaged on their journey over, or using them to train our technicians before they go offshore. So if we go onto the towers, the towers come in 3 different sections, as you can see here labelled on the right: the top, middle, and the door section. The top section is the one that attaches to the nacelle, and the door section is at the bottom and attaches onto the transition piece when the turbine goes offshore. The full height of the tower is 111 metres, and each section is about 250 tonnes, with the door section being the heaviest as it contains the majority of the technology. There's a ladder going all the way up inside the tower for the technicians to climb when they need to go up into the nacelle when it's offshore, but there's also a lift because it's such a long way to climb. So if we go onto the blades, there are 3 blades on each of our turbines, and each one is about 107 meters long. The tip of the blade needs to be really strong as it has to withstand high wind speeds, powerful rain, and harsh conditions. Therefore, the 30-meter tip at the very end has an extra layer of protection, as it's not easy to fix a blade when it's 100 miles out to sea and 150 meters up in the air. There's also a lightning protection system within the blade, so that the turbine isn't damaged if it gets struck by lightning. And when it gets really cold out at sea, the blade has a system inside it that melts off the ice, so it doesn't get weighed down by a thick layer of ice. We might have a question, yeah. So, do you think it's true or false that Big Ben is taller than one single blade of the Haliade-X? Keep going.
How close is it? Are they nearly the same height, or is there a big difference?
No, they're close, nearly the same height.
I think Big Ben is 96 meters and Haliade-X blade is 107 meters.
So go on to how is energy actually produced? How do our turbines actually produce electricity for you to use in your home? So when the wind blows, it provides kinetic energy, which makes the blades spin. The blades are then connected to a generator inside the nacelle, which transfers this kinetic energy into electrical energy. Energy can't be created or destroyed, just transferred from one form to another. So technically, we don't make electricity, we just convert the kinetic energy from the wind into electrical energy for you to then use in your homes. So how long do you think just one full spin, so 360 degrees, of our blades can power one single UK household for? So one single spin of our blades powers a UK household for 2 days. But when you think we've got 277 turbines, it's quite a lot. So onto the nacelles. Our nacelles are like the engine of the turbine. The 3 blades are attached and spin in the wind, and the generator inside the nacelle then converts this kinetic energy into electrical energy, as we've just learned. You can see from the pictures they're huge bits of very complex machinery. They're about the same size as a 3-story house and weigh about 800 tons, which is about the same as 55 double-decker buses. I'll now pass you on to David, because I think he's got a fun little task for you.
Yes. Hello, everybody. So my name is David Warren. My title is Commission and Resource Leader. So that means I'm the manager of the technicians who commission and also install the wind turbines at the Dogger Bank project. Have quite a big team, a lot of talent there, a lot of skill set to keep me busy. But today we're going to move on to our activity, which is getting you all to make your own DIY wind turbine. So can you confirm that you have all the provisions that you need to make this? So the supplies that you need for that is a piece of A4 paper. You need a pencil with a rubber top, some scissors and a push pin.
Whilst we're waiting, I think we had a couple of questions left over in the chat. So I'll just ask those now. For how many years has GE been making wind turbines? I believe GE first got into the wind industry in 2002, if I'm remembering correctly.
Yes,
so it's been a number of years since we've been involved with the wind industry. But the current turbine that we're producing, the prototype was constructed in 2019. So that's how long they've been producing the Haliade-X.
Yeah.
And then we've also got a question. Somebody wants to know more about the lightning protection system. If we have any more information.
So essentially, I can tell you about that one if that's okay, Charlotte. Or do you want to do it? So essentially, that the lightning protection system in the blades, it ensures continuity to the earth from lightning strikes. So it essentially the blade needs to connect to earth, like via the tower, via the transition piece down to the sea, down to the seabed. So the lightning protection system ensures that all the turbine, like the large turbine components, towers, nacelle blades, that they all have continuity down to the earth. So if lightning does strike, that energy can dissipate down to the ground, down to the seabed, down to earth. So that's what the lightning protection system is for. So if the potential, if the turbine connected to the ground, it's going to, the lightning is going to take the easiest path. So the lightning protection ensures that rather than the lightning travel through the actual body of the blade into the steel of the tower, or through the composition of the material that builds up the blade, it takes the easiest path, which is down the lightning protection system. So essentially, it's minimizing damage to the turbine. So if it gets struck by lightning, you get no damage at all. And I was a wind farm manager for many years before this and other projects, and we had turbines that had lightning strikes, and we saw no damage thanks to the lightning protection system. So it really does work very well.
Thanks, Dave. I think maybe we can get started now.
Yeah, okay, no problem. So to make your DIY wind turbine, the first step that we're going to do, you've got to position your paper so it's portrait, so it's upwards, right? Then you've got to fold the top corner to meet the edge of the paper. So essentially, you need to form a square, and you do that by folding a piece of paper over, cutting off the excess. So essentially, you've turned the A4 piece of paper into a square. So that's what you all need to do. So what to do? You need to fold the paper the opposite way. So essentially, you're forming a square on the piece of paper, just like on this slide there. Okay, so the next step is, as the slide details, you need to cut along the red line. So you need to cut each corner towards the middle, but just halfway down. So cut where the red lines are. Okay, so the next part of the process is bring every other corner into the center and make sure they overlap so you can hold them in place with one finger. And the second one, don't make a crease along the lines curve. You need to allow it to curve. So if you just follow those two steps, and just like the photograph.
So what you want to do is make sure your push pin goes through the center and gathers all of the layers that you folded in the middle, and then goes into the rubber of the pencil, so it's all held together by one point.
Yeah.
Feel free to decorate your wind turbines after the presentation, like David has with his jazzy stripes pattern.
Go faster stripes on. Yeah.
While we're waiting, we've had the same question in the chat a couple of times now, so I'll just ask it now. If the turbines are made out of metal, why don't they rust in the water?
That's a very good question, but they have a very good protective. Essentially, they have very good paint, and the paint is so good, thick and strong that it would prevent corrosion. But that is a very good question.
Very good question. So they've got like a lifetime of about 25 years, haven't they?
Yeah.
Without any proper preventative measures needing to be taken place.
Yeah. So what would happen if the wind farm was essentially to operate past 25 years? It would have like an end of life inspection, where the transition pieces would be inspected, the towers would be inspected, blades for damage, and that the life extension would be permitted on the basis of the outcome of the inspections, any remedial works that might need to take place. I've been involved myself in some life extension projects on onshore wind farms where tower corrosion occurred, and we did some remedial work to remove that, repaint the towers, and they were given another 5 years. I know it's a little bit different offshore, but essentially if the transition pieces were okay and there was no severe rust detected, then the life extension would be possible. So how electricity gets to the grid is essentially how the power gets in the wind farm to shore, then to our houses and businesses, schools. So electricity runs through the cables from the generator in the wind turbine down the tower to the cables beneath the ocean. All the cables from all the wind turbines on the wind farm go to an offshore substation where the power generated is converted from AC power to DC. It then goes through a step-up transformer which increases the voltage, then it is sent to the shore. This reduces energy loss over a long distance to the shore. Does anybody know what AC and DC stands for and what they mean?
alternating current and direct
Yeah.
current.
Yeah. So essentially, as you say, it stands for alternating current and direct current. So this refers to where the electrical charge travels. Think of it like running a 100-meter race. Direct current would run in a straight line. Well, alternating current would be more like a zigzag. You would use more energy running in a zigzag. Direct current is straight to the point. So if you could go to the next slide, please, Caitlin. So how does electricity get to your home? So it is then sent through the cable called the DC link. This is like a highway for the electricity which travels to an onshore substation. The electricity is then converted back to AC for use in homes and schools, businesses, shops, etc. Essentially, this is a step-down transformer which decreases the voltage to 230 volts, which is the voltage that we need to power our homes, schools, and businesses. Right, I think we're on to Taryn now.
Yes, thank you.
No problem.
So we've just got some questions for you. We want to know what your idea is of the advantages that you can identify for offshore wind power. Okay, so yes, the first advantage is that it's a renewable resource. We will always have low and high pressures within our weather system, so there will always be wind. I think there was an answer that it's clean, Caitlin? Yes, we are not burning fossil fuels and we're not releasing greenhouse gases. Okay. Our next one is that it's cost effective once.
I can lower the cost of electricity.
There we go. Well done. So once the wind farm is built, it is more cost effective. It is a very big cost outlay to build the wind farm, but it will make it more efficient to the customer, which is us. Okay. I did see some things about less noise pollution. Yeah, it's definitely an efficient use of space. So again, it's far away from people. It's not as noise polluted as some of our energy resources can be. But it's also when we're building offshore, specifically, not so much with renewables, but offshore specifically, is that we aren't using land that could have been used for other purposes, such as building new homes or building more shopping centers, that kind of thing. And then our last one is that it creates local jobs. So there was a question earlier about how many jobs it creates. The local content just in Hartlepool at our marshalling harbour, we employ over 200 people. So it is a great thing for us to have brought to the Northeast area. And it's making a difference in people's lives already. Okay.
So the next slide that we have is the potential challenges and how we overcome them on the Dogger Bank project. So the problem that we have, it's less reliable than traditional power sources. Only works when windy.
To minimise this issue, our wind farm is built in an extremely windy area, as we said, with almost constant wind. And the Halliard X turbine that we're installing is designed to power even in very low winds, or produce power.
Yeah. So the next one, disruption to wildlife and habitats. Solution to that would be?
Again, as we discussed earlier, surveys were conducted before construction of the wind farm even begun, to analyse the wildlife and their habitats in order for the wind farm to have the most minimal impact.
And visual and noise pollution.
Again, as we said earlier, that's what makes Dogger Bank such a good location, because no one can hear them or see them from onshore.
Mm-hmm.
So I think there was a couple of other suggestions in the chat that we haven't quite covered there. So the thing about it being expensive, yes, it is very expensive to set up a wind farm, but it becomes cost effective once it's built and is producing power. You see, you don't have to spend money on fuels and things like you would with coal or traditional methods of producing electricity.
I saw that there's another question that keeps popping up. Are there going to be new ways of creating energy, keeping it renewable and not loud? As we said, there's revolutionary things like the floating wind turbine. So if you're interested, there's lots of research about turbines getting larger. So ours are currently the largest that are being installed in the world, but there's people always want to go bigger. So there's potential that for bigger turbines, floating turbines, which would all be offshore, which so therefore not loud and not in anyone's view.
We're not involved in solar farms at this stage, but there are many solar farms that are being built across the UK and the rest of the world. And that makes no noise.
Does anybody have any questions about anything that you've learned today or seen on our presentation today, or just questions about wind power in general that you'd like to ask? I think I saw a question about whether the turbines are recyclable as well.
Sure. So most of the wind turbine components that the towers, the frame of the nacelle is steel, which is recyclable. The internals, obviously, you've got the generator there, which is steel, aluminium. We've got components inside. We've got various components that can be removed and broke down further. But the obviously the main structure of the turbines is metal, which can be easily recycled, as you know. The blades are fiberglass kind of wood, so that's a little bit more difficult. But as time goes on, we do have recyclable processes that are improving for blades as well. So when this wind farm gets to the end of its design life, we should have a more improved process for dealing with the likes of the difficult things like the way the composition of the blades, the material that's made of. So but it's improving all the time. But the main body of the turbine, as we know, it's steel, aluminium, which is easily recyclable. It can be melted down, made into new wind turbine components. So it's very recyclable.
Sorry, David. We have a question about, other than wind turbines, do you think that the company will create more energy using different energy sources? Will you make more energy using other sources? So GE Vernova is actually a collection of different energy businesses. So whilst we're offshore wind, we also have other aspects of the business. So we have an onshore wind segment that focuses on wind turbines that are onshore, but we also have many other businesses that look into things like solar power. Hydropower is a big one. It's kind of focused in the Netherlands and things like that at the moment. And we also have a gas power segment, which focuses on trying to find more focus on carbon capture and how we can include things like that. So we have multiple different segments of the business that all look into different ways of powering the world, but for with less carbon production and to be more renewable and clean energy for the future. I think we have a couple of other questions in the chat as well. How long do our workers have to be offshore to maintain the wind turbines? Do the workers live in the turbines, or do they have boats?
I can tell you that. So we have the wind turbine installation vessel, which is a large vessel with a big crane that assembles the wind turbine. So my installation technicians who work on that, they work on their 3 weeks off, 3 weeks off. So they don't actually stay in the wind turbine. The installation vessel, although it builds a turbine, it's a kind of floating hotel. It's like a cruise ship and a work ship all in one. And that has accommodation. I've been on that. It's a very nice vessel. They have good rooms. They have a gym, sauna in there. They have a very nice restaurant, cinema. So the technicians, when they're not at work, they're very, very well looked after. And again, on that same vessel, the work from that vessel, they go to the turbine. There's a walkway connects to the wind turbine, so the technicians, they can walk from the vessel straight to the wind turbine to do the work. They work 12-hour shifts, so it's 12 hours days or 12-hour nights, depending on who you are. And it's 3 weeks on, 3 weeks off for the installation vessel. So you go to work 3 weeks, work 3 weeks worth of 12-hour shifts, then you come home and you have 3 weeks off. For the SOV vessels, so for the smaller vessels that support the commissioning and activities, again, it's a floating. It's a very nice vessel. The guys are based from there. That the sort of the teams that we have all sorts. We have the client on there. We have high voltage technicians on there. We have the commissioners on there. We have a whole raft of guys and girls on that vessel working, supporting the project. And again, they're very well looked after. They have very nice rooms. They have a workshop on there. They can prepare the tooling, the parts needed to commission. That vessel goes alongside the turbine. There's a walk-to-work system connects, and the technicians walk to that wind turbine. They go and do the commission activity. So it's a twofold thing. The turbines are installed, and the commissioning teams go in and essentially make that installed turbine run and make power. And my commissioning team, they work 2 weeks on, 2 weeks off. And so they go to work 2 weeks, 12-hour days, and they have 2 weeks off at home. So if everybody who's working offshore, they stay on the vessels, they're in the North Sea for 2 weeks, but they're very well looked after, and I've seen it myself, and I'm very jealous. So there we go.
We have a question about where the steel is made that the turbines are made of. The materials.
So obviously we get the towers come from Spain, I believe, and the nacelles are France. So most of the steel comes from steelworks in Europe. So it's our components are made in Europe and brought together to the Marshall Harbour. So obviously it's European steel mills that support the production of our turbine components.
Super. And how long does it take to build one wind turbine?
I believe, correct me if I'm wrong, Taryn, and I think it's 18 hours. That's what we've got to build it within 18 hours. One turbine, 18 hours.
That is the target, yes. There are different sections that the towers get built in. So we build a little bit of it onshore, and that's a different team that will continue the building and finishing the building offshore. At the moment, we don't have solid numbers. We only have a target, and we will do our best to reach the target for now. We can come back to you after a couple of installations and let you know how that is going.
Yeah. But essentially, the transition pieces are put in first. They're ready, and when the installation vessel gets to site, it has 18 hours to build that turbine, and it can be done. It's a bit tricky to obviously finding our feet, but
we're getting there.
We're getting there. Yeah.
Super. I don't think we have any more questions, but I just want to reiterate that our next section will be on the 15th of May, and I think that is our careers spotlight. So we will see you all again then. It's been lovely to see you all. And thank you for the participation. We had a lot of activity in the chat. That was great to see. And then I can see everyone walking away with their wind turbines. So that looks really good as well. So thank you all for joining the call.
Thanks so much, Caitlin, David, Taryn, and Charlotte.
It's been great.
Really good session today.
Thank you very much, everybody.
Seeing some of you next time.